Welcome to this tutorial on using blockchain technology for decentralized cloud storage. In this video, we will explore how blockchain can provide a secure, transparent, and efficient method for storing data without relying on a central authority. For the purpose of this tutorial, we will build a simple decentralized storage system using Java and a smart contract on the Ethereum blockchain. We will cover the setup of the development environment, creating the smart contract, and implementing the Java application to interact with the blockchain. Let's start with an overview of the components we will need. First, we will need the Java Development Kit, JDK, Apache Maven for project management, and Ganache, a personal Ethereum blockchain for testing. You can download these tools from their official websites. Once you have installed the development tools, open a terminal or command prompt and create a new Maven project. Use the following command to create a basic structure for our project. Navigate to the newly created project directory. Next, we'll add the necessary dependencies to our project. Open the pom.xml file located in the root of the project and add the following dependencies for Web3j, which is a Java library for integrating with Ethereum. Now, let's set up Ganache. Open Ganache and create a new workspace. This will provide us with a local blockchain for development. Make sure to note the RPC server address. Typically, it will be http://127.0.0.1:7545. Next, we will write a smart contract for our decentralized storage solution. Create a new file named storage.sol in a directory called contracts. This smart contract will allow us to upload files and retrieve their hashes. This contract contains two functions: upload file for storing a file's hash and retrieve file for fetching that hash using the file name. Next, we'll need to compile this smart contract using Truffle or Solidity compiler. If you're using Truffle, navigate to the Truffle directory and run. After compiling the contract, it's time to deploy it to the Ganache blockchain. Create a new migration script in the migrations directory. Name it to_deploy_storage.js and add the following code to deploy our storage contract. Run the following command to deploy the contract to Ganache. Once the contract is deployed, record the deployed contract address from the terminal output. We will use this address in our Java application to interact with the deployed contract. Now, let's create the Java application to interact with our smart contract. Start by creating a storageservice.java class in the src/main/java/com/example/decentralized storage directory. Here, we'll add methods to connect to the blockchain and call our smart contract functions. In this code, we create a storage service class that initializes a connection to our local Ethereum node, loads the wallet using Web3j, and interacts with the storage contract using the contract address. Next, let's implement a main.java class that provides a simple menu-driven interface to upload and retrieve files. Create a main.java in the same package. In this main class, we use a scanner to read user input and prompt for either uploading a file or retrieving a file's hash. Based on the choice, we call the relevant methods in storage service. Compile and execute your application. Make sure that Ganache is running and the smart contract has been deployed. Also, ensure that you have a funded Ethereum address to interact with the blockchain. As you run the application, you should be able to upload file hashes and retrieve them by file name. This demonstrates the power of using blockchain for decentralized storage solutions where data integrity is maintained and there is no single point of failure. To wrap up, we have successfully created a simple decentralized cloud storage application using a Java application and a smart contract deployed on the Ethereum blockchain. This project serves as a foundation for further enhancements, such as adding file encryption, handling larger files, and implementing user authentication. If you found this tutorial helpful, please give us a thumbs up and subscribe to the channel for more content on blockchain and decentralized applications. Share your thoughts and suggestions in the comments below.